Alright, welcome back. I'm house sitting for a friend, so I am in a non-familiar place. Just brought my computer with me so I don't have to have any sort of excuse for improper setup. So we left off yesterday with trying to do a... Oh, actually, we already did it. I forgot we did this yesterday. This obstacle populate function, which allows us to just populate a one stack of any given type and color. So that's cool. So I don't exactly know what we're going to be doing today, except we can start with fixing this bug, which is we just picked up 5 stones, and the only place, I mean, we're stuck now because we can't, there's no legal moves around us. So before we pick up 5 stones, actually, so there's 2 ways of thinking about this. We can either take all the stones out and then allow us to drop, and as soon as we drop it in, do you see how, actually, hold on. These are all legal move trues. Let me reset here. Okay, so these are all a legal move true, except if we lock this in, it's a legal move false because we have too many occupants. So we could either, trying to think of the best thing to do here. We could do, so I'm thinking what we do is allow us to pick it all up, but if enter is pressed, yeah, we would need to stop. Hey, Rosie. We would need to stop. You want to say hi, Rosie? Yeah. Hi, sweetie. Hi, sweetie. Oh, sweet love bug. Okay. So if we allow our person to pick up stones, even though there's no legal move for picking up the max amount of stones, we would then need to limit how many stones we lock into our hand. So picking up 5 is fine, but, and I think we started talking about this at the end of yesterday's episode, where we need to get the lowest amount because basically we need to make it, since there's 13 and 11 stack, so if there's an 11 stack, then if we lock in 4, it should still allow us to move on to a movement event 3 and place it in what then would be the only legal move over here. Oh, no. Hold on a sec. We would need to have two stones. No, 3 stones in our hand, and if we lock 3 stones in our hand, 3 plus this 11 stack would be our limit of 14, which is rendering as a legal move here, which is correct, and these are incorrect, which is correct. So, we were allowed to do that move, so we need to basically count the lowest amount of stones surrounding us and make sure that, and then by the time we press enter, we need to make sure that our mouse stones plus our lowest amount occupied does not go past 14. Do we have this lowest amount occupied or something that we're talking about here? Lowest surrounding occupants. Did we do this already? Lowest surrounding occupants. Oh, okay. Oh, we started it. That's right. Okay. So you guys, I went to the Greta Van Fleet concert last night, and I programmed this in the morning, and then I had to drive back from El Paso today and get settled in. So my mind's a little lost in terms of where we left this yesterday, even though we just did yesterday. It feels like more than that. So yeah, so we're already on it. We're already making this function called lowest surrounding occupants. We've done our corner cases. We just need to do our edge cases, then our middle cases. So then we can put this in our movement event 2 logic, which is if we press enter, unless our mouse stones, or we would say like if our mouse stones plus the lowest surrounding occupants number is more than 14, then don't do anything. Otherwise, go ahead and lock those stones in. So we should be good to rock and roll. So let's get our edge cases done. So we're checking the edge cases of our movement origin. So our origin row, and our origin column. So we're trying to, we pass in origin row and origin column, and what these parameters are calling origin row and origin column, we will actually pass in our movement origin row, movement origin column, and that'll count how many surrounding occupants, what is the lowest amount of surrounding occupants we have. See, and it's not that simple because it's lowest surrounding occupants that is not a capstone, which we cover right here by making sure that stone control would have to be a lay stone in order for this to matter. So we did a pretty good job yesterday morning when we thought that through. So let's just continue on now. Our edge cases, if we start with our top edge case, then our origin row would be equal to 1. And our origin column would not be equal to 1 and would not be equal to 5, meaning we are in our first row, but our column is not 1 or 5. We're not the top left case or the top right case. So we would be a top edge case. So we can say, at this point, we need to check all of those surrounding. Now this would be a top edge case. And the reason why we separated it by these different cases is because different spots on the board have different arithmetic to check for the surrounding grids. So the corner cases only have 2 grids to check, and depending on which corner you're in, you check different grids. So this would be the bottom case. Gosh, this is a new mouse I'm not used to, so it's a little wonky, but make it work. don't get why it doesn't auto-indent that for me. I always seem to have to do that for else ifs, which is a little annoying, but let's do our left one, which would be an origin column of 1 and origin row would not be equal to 1 and origin row. When I was starting out programming, I would get confused with using ands or ors, because we're trying to, like in this case, we're trying to see if, like, we don't want it to be equal to origin row 1 or origin row 2, but we actually need the and because we need the inclusive. It can't be equal to either of those. Yeah, 1 and 5, not 1 and 2. So origin column 1, origin row 1, and not 5. That should be our left edge case. And I'm not doing an else here just because I want to be explicit about it. Now our right edge case would be a column that is equal to 5, and we would want our origin row to be not equal to 1 and not equal to 5. Then don't really need to worry about our middle cases, but so now under each of these cases we need to do the appropriate logic for the surrounding squares, and the surrounding squares for a top edge case would be left of the square, down of the square, and right of the square. The bottom edge would be right of, or let's start with, so we got left of the square, up of the square, and right of the square. Now, left edge case, gosh, this mouse is something else. Right edge case. Okay. Left edge case would be up of the square, right of the square, down of the square, and right edge case would be up of the square, left of the square, down of the square. Now what that means is, you're kidding. I don't know where it's mad at me, dude. I've got a then there. I don't know why it's mad at me there. Because this was supposed to be an equals. That's why. So what these mean, left, down, right, left, up, right, down, up, left, down. What that means is those are the scores we need to check. Oh, come on, man. What are you talking about? If I run it and it works, that's just the stupidest thing to me. Why? Like I was about to go look at what it said and go find it, but I had a feeling that it would just work if I did it again, and it did, which I'm gonna blame Lua as an interpreted language for that problem. I don't know exactly why that would happen, but it's like, you know, if you're trying to compile your code in C and you just compile it, and there's an error, and then you try to recompile it without changing anything and it works fine, like that should never happen. I don't know what happened, but... So look, if it's a left edge case, we need to check up, right, and down of our left edge. If it's a top edge case, we need to check left, down, right. So that's what those code words mean, because we only need to check 3 spots, as opposed to our corner cases, we need to check 2 spots. And when we get to middle cases, we need to check all four of our surrounding spots. So we're going to say, yeah, basically, we need to basically copy what we did for the corner cases, just we do need to check manually 3 cases instead of 2 cases. So our left case would be our grid, and instead of corner cases were unique, so we could do the numbers here hard-coded in for the corner cases, because each corner case had a unique space. Only one corner case, like we could hard code these in because the corner cases only happen, you know, a specific logic for a specific corner case, whereas there's 3 cases we could do our top edge logic, our top edge case. So we need to do this based on our origin row and origin column now, instead of hard coding in the numbers. So left would be same row, so we can pop in our origin row, but then it would be a column to the left, so origin column -1, and we need to check. I'm not going to do the stone control just yet. I'm just going to kind of build out that we need all 3 of those cases. So our down case would be same column, 1 row incremented. So the same column, and then our last case would be our right, which is same row, 1 column. So we would say grid, our origin row, and then our origin column +1, and then we're first checking if this stone control is a lay stone, because we're only gonna worry about incrementing our lowest surrounding occupants variable on surrounding stones that are of a lay stone, because you can't place on a capstone or standing stone, so we're only checking available moves and the lowest amount of stones on an available move. So we're checking stone control for a lay stone here, and then we need to do, if we don't have a lowest surrounding occupants just yet, we would say, you know, so if this is equal to 0, then we need to go ahead and assign our lowest surrounding occupants right then and there to be that grid's occupants. So we can say this. Hi, sweetie. So nice to snuggle. She's usually shy, so it's nice that she's out here to snuggle. So we're going to say that occupants gets assigned to that corner or that edge case's occupants. So it's a lot like the code we did yesterday for our corner cases, except we got to check one more spot than normal. And if we're not already nil, we need to check whether or not this grid's occupants, so this can be, this one's not occupants, and we're checking to see if that is less than our current lowest surrounding occupants. And if so, then we would go ahead and assign our lowest surrounding occupants to be equal to this grid's occupants. Is that right? So if our occupants is less than that value, yes, then we're going to assign it. If that value is nil, then hey, careful. That value is nil. It hasn't been assigned yet, so that would be the case if there was only. Oh my God, she almost knocked my phone on the floor. It's okay, sweetie. Hi, silly. Thanks for snuggling. Yeah, so the case I'm talking about, if it's nil, that could mean there's only one available surrounded spot that's populated. And in that case, it would be equal to nil. And if it's equal to nil, this is going to be equality here, not assignment. If it's equal to nil, then we're going to go ahead and assign it right then and there to that grid. Okay, cool. Otherwise, we only assign it if that amount of occupants is lower than our current lowest surrounding occupants, and then it becomes our new lowest surrounding occupants. Cool. So we've got that case done. We've got the left edge case done. Now we're going to do the bottom case. So we're checking stone control for equality, just like we messed this up too. This is an equality, not assignment. We're checking for equality to a laystone type stone control. And if it's a laystone type stone control, we're going to see if we are already assigned a lowest surrounding occupants. If it is, we're going to go ahead and, if we don't have lowest surrounding occupants already, we're going to assign that lowest surrounding occupants to be equal to this bottom grid dot occupants. Okay. Now, if it's that, else if, we would also assign it if that grid's occupants is less than the current lowest surrounding occupants. If that's the case, we're going to go ahead and update our lowest surrounding occupants to be equal to this grid's occupants. Now we just need the right case, then we're done with our top edge cases. So we're going to check for laystone stone control, not occupants here. Stone control. We need an end here as well. Okay, laystone. Then we don't have a lowest surrounding occupants yet. We would get one. else if our occupants is lower than our current lowest surrounding occupants, then we're also going to go ahead and update this value. Don't forget our end. Now that should be the end of our top edge case. So see, we have to check 3 spots now for every top edge case, as opposed to 2 for each corner case. And we can't hard code in the numbers like we could for the corner cases. Okay, bottom edge, let's go. We're gonna first get all of the grids we need to manipulate, which is left of our movement origin, up of our movement origin, and right of our movement origin. So left grid would be our grid. Left would be same row, just a column to the left. So origin column -1 is to the left. Then we need to check the up case, which would be the same column, but one less on our row here. So origin row -1 to be above, and then origin column, same column. Okay, now we need the right square, which would be same row, column over to the right. So our origin row, it would just be an origin column +1. Not dot occupants, but dot stone control relay stones. Okay. So now that we are checking our stone control, now we need to do what we've been doing, which, if our lowest surrounding occupants is not yet assigned, then we'd go ahead and assign it to this grid. So we need this dot occupants. Now, we need to also update that value if our grid occupants is less than our surrounding occupants. So less than the current one we used to have. This is our new low at that point. Cool. Now we would need this. So if we haven't assigned a surrounding occupants yet, we're going to go ahead and do that with this grid's occupants. Else if that grid's occupants is less than our lowest surrounding occupants, then we're also going to update it. Okay. last, for our bottom case, we're going to be doing if lowest milestone or lowest surrounding occupants is equal to nil, then we're going to go ahead and update lowest surrounding occupants to be equal to that grid's occupants, else if that grid's occupants is smaller than our lowest surrounding occupants, then we also need to reassign it. Cool. We need an end, and then I think that's right. Okay, 2 more to go. We need left edge case and right edge case. Now, we need up, right, and down. So if our grid up would be same column, 1 row shifted up, so origin row -1 with the same column. That would be up. Checking stone control for equality of a lay stone. Hi there, Rosie. Hey, sweetie. Now, we need the right stone, so sweetie. Else if this grid, we need hi. Right would be same row to the right column. So we need origin row with a column 1 to the right. So column plus 1. Okay. Now we need the down grid from our movement origin. So we'll say else if our grid would be down would be 1 row down. So we would have a +1 right here and a same column, because is that right? Hi. 1 row down, yes. Same column, yes. Okay, yes, that's right. Then we're checking for... You're a little love bug today, Rosie. Yes. Hey, sweetie. My productivity speed has shifted, but that's okay. It's okay. You're worth it. Yep. So yeah, those are the 3 grids we need to check. So now we can do our magic. Rosie, you silly. So we're gonna say if our lowest surrounding occupants is nil, we're gonna go ahead and assign it to be equal to this grid's occupants. Now, else if our grid's occupants here on our up case is smaller than our lowest surrounding occupants, then we're going to go ahead and update it with our up new lowest surrounding occupants. Then we're gonna say lowest surrounding occupants is equal to nil. We're gonna go ahead and assign that to be equal to this amount of occupants, else if our occupants is less than our lowest surrounding occupants, then we need a new lowest, which we would assign right here by saying this. Okay, last one, the down case. So this is for our left edge case, so this would be the square right below us. We only care if it's a stone control of a lay stone, because you can't place on a capstone or standing stone. Then we're going to ask if we're nil on this value. And if we're nil on that value, we're going to go ahead and update that value and give it a value in the first place. And it's actually this dot occupants that we want to give it. I just noticed we did some stuff wrong here. Actually, no, that's right. Yeah, that should be right. Okay. We're good. Doesn't hurt to be safe, though. Double check our work. This is basically the same code over and over and over, just for specific surrounding cases. And then we need an end and an end and an end. I'm pretty sure, yep. If, else, if, else, if. Yeah, we don't need this. What is going on? What end are we missing? Right here. And right here. Okay. Okay, last case for our edge cases before we move on to middle case. And this is the right edge case, so we need to check above us, to the left of us, and down below us. So let's first do above us. That would be one row above us, or origin row -1. Same column. Then to the left of us, which would be same row, one column to the left, column -1. Then we're gonna check beneath us, which is gonna be a row of a +1. One row beneath us at our same column. Okay. Now, we're gonna first check if this is nil. If it is nil, we're gonna say if nil, then we're gonna go ahead, set our value to be this grid's occupants. Now, we would need the other case, which is if this grid's occupants is less than our current lowest running occupants, then we're going to go ahead and update it. Okay. Next. First, we're going to check if it's nil. So we're going to say if this is nil, we're going to go ahead and assign it. Else if this occupants is smaller than our current lowest running occupants, we're going to go ahead and assign it in this scenario as well. And we can simplify this code. We could ask if it's nil or if it's less than the surrounding occupants, but I don't exactly know how the interpreter works because we have to ask this first, because if we're evaluating actually, yeah, we should be able to consolidate that, but we'll worry about that once we get it working. Then we can make it look pretty. I'm just trying to get it working first, so yeah, I've never done an or in an if statement when one of them is asking if it's nil. I would assume I don't know enough about it. It should work. It should work. We should be able to get rid of a couple lines here, but I'm going to update our lowest surrounding occupants to be equal to that grid's occupants. Yes. Okay. Last one for our edge cases. So if that grid, nope, if this value, lowest surrounding occupants, no, this is our variable, not our function. We're actually in our function right now. We're testing this for equality to nil. And if it is, we're going to update it. And we're also going to update it if that grid's occupants is less than the lowest surrounding occupants. We're also going to do the same thing. So that's where we can cut down some lines if it works to pair those two into one conditional statement. Which it should work, but I've been wrong before, so. That looks like we've got all our edge cases. Top edge, bottom edge, left edge, and right edge. Okay, now we need our middle cases. Actually, maybe we pause there for tonight, because I'm exhausted from all the traveling I just did today. Middle cases is going to be fairly easy. We don't have to do. Basically, we just say if column and row does not equal 1 or 5, inclusively doesn't equal any of those, then we're going to go ahead and search all the surrounding squares. So that one should be pretty easy. And then we can evaluate whether or not we have been tackling this function correctly, and if it's working, and if it solves our problem ultimately. So far this function is actually kind of big, because we're checking all these things explicitly, but we need to. Yeah. Okay, yeah, I'm tired. I'm gonna go ahead and commit for the day. We're gonna say added edge cases to our lowest surrounding occupants function. Nice. Push to our origin main and call it a day. I'll see you guys tomorrow. We'll do our middle case inclusion to this function, and then we'll actually test the function and see if it solves the problem we're hoping it does. So yeah.